My name is Dmitry Sorokin, and I am CTO of AnalyticsCreator. And today I will present you AnalyticsCreator. AnalyticsCreator, this is a data warehouse generator. AnalyticsCreator can generate the data warehouses, Microsoft SQL Server data warehouses. And now, today I will show you how AnalyticsCreator works and how you can create a pretty complex data warehouse based on SAP as a data source in very short time. Okay, let me start AnalyticsCreator, and I will show you how you can create your data warehouse. Well, AnalyticsCreator is running, and I hope you can see my screen. Can you confirm, please? Can you see my screen?
It's just changing the screen all the time. I don't know.
Oh man. Okay, wait a moment. Let me. You have a look. Aaron, can you confirm?
Right now it's okay. Yeah,
okay. Okay. At last. Okay, I just started AnalyticsCreator and created the, and now I will create the new data warehouse project. We can call it GMO SAP 1, for example. Now the new data warehouse project is creating, and let's wait a little bit. Okay, we created the empty data warehouse repository. This is a SQL Server database containing the whole information about our data warehouse. This is data warehouse project. And first, what we will do, we will add connect. Yes,
Dimitri, we don't see you.
Yo,
no screen.
Oh man.
I can see.
No screen, no voice.
I can see and hear.
Okay, Peter, I think it's Peter's problem.
There are other persons which are saying that.
Yeah, I can see and hear.
Okay, what we can do? There is something wrong with internet today. Aaron, you can see and hear my voice.
I can see and hear. Yeah, I can see your screen and hear your voice clearly.
Okay, then I will continue and hope that others can see and hear me too. Okay, we will record this session and store it on YouTube, and therefore, if you want, you can see, I hope, this session in YouTube. Okay, then I will continue. Okay, now we have we created the empty data warehouse project, and first what we will do, we will add a connector to the data source. In our case, this is SAP data source, and there are two ways how we can create connector. First, we can create connection to the existing data source. I can click on create connector, and here I can add connection string to the existing database. We support different kind of databases like SQL Server, Oracle, text files, SolidDB or DBC, and many other sources. Among other, we support connection to the SAP systems, and because we can read natively the metadata from the SAP. But in our case, instead of it, I will use the meta connectors. Meta connector, this is the information about the sources, the source tables, source columns stored in our cloud, on our cloud server. And for example, here I have some connectors. One of them is connector, Shopify connector. The Shopify connector, as I said, this is the information about SAP tables and related, for example, to Shopify and controlling area. And here you can see that there are the different SAP tables related to Shopify, and I can use this meta connector instead of the true SAP system and can create my data warehouse using this meta connector. For example, this is a well-known BKPF table. This is accounting header table. And here you can see the full structure of this table, but this information we got from our meta connector, not from the SAP system. Later, I can connect my connector to the real SAP system and compare the metadata. If there are, for example, some new columns, they will be recognized and added to the meta connector. Well, and why not? Let's connect this meta connector to the SAP system. To do that, we can go there to the properties of this connector. Okay, and here we should add the connection string. Okay. This is a format of this connection string, and let me take a look on. Okay, this is how our connection string should look like. But to enter the password, I can use the new feature of AnalyticsCreator. This is the encrypted strings. First, I will create the encrypted string SAP. It's just a way how to store the password, for example, to avoid that the password will be shown. And now the connector, I can use this encrypted string and use this encrypted string instead of the password. Okay, we just connected our meta connector to the existing SAP system. Well, what we will do, now we will launch the data warehouse wizard. Data warehouse wizard will help us to create a new data warehouse very briefly. Let's select. There are the tables already stored in our meta connector. Surely we can read the metadata directly from the source database, or we can use already defined tables. Okay, we will take booking header table, booking position table. We can take customers. We can take vendors. Okay, company codes, document types, document type texts. Okay, let's take counts too. Well, we will create the Kimball data warehouse using facts and dimensions. AnalyticsCreator supports different kind of architectures like Kimball, datavault. In our case, we will create the full Kimball data warehouse. We will create for every table, we will create dimension, except, for example, this T003T, they are the text of the documents, and instead we will use this table to create combined dimension containing T003 and T003 tables. Okay, we will create the effect transformation based on booking position table. And okay, because we will combine T003 and T003T, we will create the transformation between the staging and persistent staging layer. And in this transformation, we will combine these two different tables. Okay, I think that's that. And here on this screen, we can define the names of the tables and objects and transformations which will be created by AnalyticsCreator wizard. For example, every dimension will have dim prefix in the front, every fact will have fact prefix in the front. Okay, on the next screen, we can define some additional properties. For example, calendar dimension we will create it, and there is a list of the schemas will be created. Anyway, let's click on finish and wait for and wait a little bit. The wizard will analyze the metadata stored in the connector. In this case, this is unimportant if you use meta connector or if you use the connection to the true source system. Wizard will analyze the metadata and create for us the draft version of the data warehouse. Okay, here you can see that this is a typical data layer diagram of the data warehouse. From the left to the right, first this is the source layer, our sources. If I click on, for example, here, I can see here the definition of our PKPF table. We got okay, nothing specific. Okay, and here in the staging layer, you can see the data in our data warehouse. This is the import layer of the data warehouse. We import the data from the source into the staging layer, as is, I would say. And next layer, this is a persistent staging layer containing historized data. We perform the data historization. It is not necessary to historize the data, but we always suggest to use the data historization. This is very powerful mechanism to have access to the previous versions of your data, and therefore historization is very useful. Then we have here the core layer. Core layer will be used usually to convert the data into the facts and dimensions. And data mart layer. This is the interface layer of our data warehouse, and this layer, the structure of this layer will be later used to generate, for example, multidimensional or tabular OLAP cubes or Power BI models. Let's take a closer look to the import. For example, import will be done using integration service packages or Azure pipelines, and the definition of the import is stored here. You can access the definition of the import if you click on this IP square. This is import package square, import package definition, and here you can see, for example, this is a mapping between source and target columns. What we can do here, for example, we can define here the different variables and use them as a filter. And in our case, to restrict the data which I will import, I will create here the new filter. This is a Geschäft GR. This is a here of the booking here is greater or let me do it, equal the year variable, and this variable to type integer, we will add here, and we will take, for example, the year 2030. You can manage the value of this year variable using this special table called SSS configuration. Every variable is stored in this table, and you can set the value of this variable prior to start your, for example, integration service package. And in this case, we can manage the data which we import from our data source. Using this mechanism, for example, you can organize a differential data loading. It works very good. Okay, it's the same filter I would add to the import of the data from booking position table. Okay, here is equal year variable. Okay. Well, what I will do additionally, this table, T003T, contains the document type texts, and here I will create the transformation containing all columns from the document types, this T003 table, and the additional text for every document type. If you take a look on this transformation nothing more than a view. The AnalyticsCreator supports different kind of transformations, but the most common and most useful transformation in AnalyticsCreator, this is a view. It can be a view generated by AnalyticsCreator itself, or it can be manual created view. We support, of course, different other kinds of transformations like storage procedures, scripts. You can generate your own, for example, integration service packages, and use them as external transformation. But as I said, the usual transformations, this is a view. And here I would add one additional table to our transformation. This is T003 T003T. Okay, and these two tables are joined using one reference. Every document type in the table T003 has several related rows in this T003T table for different languages, and we will add one filter to this T003T table to restrict the text data which we will import. Let's do it to punct. As per IS is equal E. This is the English language. We will get only the English text from this T003T table. And from this T003T table, we need only the column L text containing, okay, let's call it L text, containing the document type texts. Okay, now we have the combined dimension. If we take a look on the view generated by AnalyticsCreator, you can see the two tables, T003T, 3 and T003T, and there is a join condition. We get only the text for the language English from T003T table, and created the specific new. We will expose this text as a column L text in our transformation. Okay. Let me click on the Synchronize the Hub button. If I click on Synchronize the Hub button, the structure of this data warehouse, which I created, will be materialized, and the new database will be created on my SQL server. Here, for example, I have the SQL server, and if I take a look there is, for example, the first database. This is a repo demo SIP1. This is database containing our repository, and one more database was generated right now. This is DWH demo SIP1. This is a database, and this is the empty database with the structure of my data warehouse. You can see here different import tables, STG tables, this is historizer tables, and so on. AnalyticsCreator analyzed the references, relations between the tables, and you can see now this doc type transformation depends on two different tables, doc types and document type texts. Okay. We created now the combined transformation, and on the next step, we historicize the data. Persistent staging layer usually contains the historized data. It is not necessary to create the persistent staging layer with historized data, but as I said, it's very useful. Let's take a look on the historization, how it works. If I click on HP square, this is the definition of the historization. But first, what is the difference between the import and the historized table and the common table? If I take a look on, for example, this historized BKPF table, I will see that this table has 3 additional columns. 2 of them, this is these 2 columns, .funhis, .bcs, this is a date from, and date to, this is a validity period of specific data row. It tells us when the specific data row was active, when this data row was created and maybe was deleted. And there's one more additional field called SATS ID in our case. This is the identity column of the type big integer. This is the surrogate key, because historized table contains the history of the changes or different versions of specific data row. Therefore, for one primary key, business key, it can have several data rows. Therefore, we need an additional technical key, which we can use later to address the data on this table. And this is a surrogate key. In our case, this is the column called SATS ID of the type big integer. All names, of course, are configurable. You can change the names of such columns, but names should be unique for the whole data warehouse. Okay, and how the historization can be configured? It can be configured very, very widely in AnalyticsCreator. First, you can decide for every column which historization type you will use for a specific column. SCD2 means this is a full historization. In case the column is changed, the new data row will be added to the historized table. For example, for some less important columns, we can select historization type 1. In this case, the changes in specific column will be detected, and but no history of the changes will be stored in the historization table. That means, in case only this specific column, for example, was changed, the value of the actual row in the historized table will be changed, but the history of the changes will be not stored. You can select such historization type for example, the columns which will be frequently changed, but which change history is unimportant for you. Or, for example, you can exclude the specific column from the historization. In this case, that means when only this specific column is changed, no changes will be performed in the historization table. Okay, here is a lot of other properties which you can manage, which you can change. For example, what we will do in case the data in the imported data are missing, for example. The specific row in the source table was deleted. What should we do with the historized data? Close means the validity period of the specific data row will be closed, and the valid to date will be set. You can say do not close. In this case, the specific data row will continue. Will be not closed. At empty record, this is one specific way how to manage the deleted data rows. In this case, for example, we can generate the specific empty records. It's important to close, for example, the gaps in the historization. Sometimes it's very useful. You can define the different filters. In this case, you can restrict the historized data for example, for only the data in the last months or in the open period, for example, the actual and previous month. In this case, it is not necessary, for example, to import all the data. You import only the data, for example, for the current and previous month, and to avoid that the missing data, old data will be closed. You can define here the specific filters. You can change the. There is a lot of possibilities how to configure the historization. You can historicize already historized data. In this case, if your source table is already historized, AnalyticsCreator will use this existing historization in the historization process. How historization works technically? For every historization, we generate the stored procedure, and you can see the stored procedure generated by AnalyticsCreator, and you can change this historization procedure. If I click here on manual creator, I can change it if I want. Usually it is not necessary, but you can maybe add some own logic to the historization, and it is possible too. And of course, for import and for historization, you can add some scripts. This is a pre-script and post-script. There are the SQL scripts which will be executed for and after historization. Then let's take a look on the core layer. Core layer contains the transformations usually. Using this transformation, we convert our relational data into the facts and dimensions. And in our case, AnalyticsCreator, the wizard just created the view containing all columns from of the specific tables, and every column will be exposed just as is. What is interesting here? First, AnalyticsCreator converted the technical names into the friendly names or business names. For example, instead of the column name BUKRS, bookers, this is we use the company code, core code in the transformation. This bookers field will be exposed as field. What is interesting? You can see here, this is a table used in this transformation. There is a list of the column. Just every column from this table was exposed by the view, and AnalyticsCreator just create the view, and you can see here this view text. What is interesting here? We have here some predefined transformations. Predefined transformations will be used to transform some columns based on its column type. For example, let me remove every column, predefined transformation, and take a look on my view. I can see every column here will be exposed as this without any change. Let me add, for example, the predefined transformation trim. And in this case, you can see every varchar or nvarchar column will have this rtrim ltrim transformation. Will use this rtrim ltrim transformation to remove trailing and leading spaces. Okay, let me add one more. For example, string null to an a. For example, this transformation will convert the null values in the string columns into n.a transform value. Here you can see how it works. Rtrim, ltrim, and then is null, for example, n.a. AnalyticsCreator, okay, or this transformation analyzes the length of the column. For example, this column is only one character length. In this case, it will be transformed into the n, not into the n.a value to avoid the type changing. Okay. And so on. Such predefined transformation, we deliver some predefined transformations, and you can create your own transformations. It's very easy how it works, and you can create your own predefined transformations. And it is really very useful, for example, to perform some type-based transformations for every column, and it can save your time. Okay, then save. Okay, now let's take a look on this transformation. Let me set the filter. If I set the filter, I will see only the object, depending on this object, or this object depends on. This is our fact transformation. This fact transformation combine the different. Okay, AnalyticsCreator, we set to the AnalyticsCreator to the wizard. It has to create the fact transformation based on the doc segment table or BSEC table, and wizard found that there are some other tables related to this BSEC table. This is a backup AF, also booking headers, accounts, company codes, and vendors and customers. And it created for us the transformation containing surrogate keys from every of this table. And in this case, it's important that every table used in this transformation is historized table, and it's pretty difficult to join historized tables together because the primary keys in the historized tables are not unique. I mean, the business keys are not unique. There are different versions of the data stored in the historized table for every business key. Therefore, to solve this problem, we use the historization type snapshot. How this historization type works. Let's take a look on the view generated by AnalyticsCreator. You can see, for example, there is a backup BSEC table, a backup AF table, and so on. Every the different tables, but here is one additional table called CFG snapshots, and this is very important table if you work with historized data. This snapshot table contains the snapshot dates. This table contains at least one data row with the actual date. But you can define, and for example, imagine there is only one row with the actual date in this snapshot table. Then we join the table BSEC to this table using this where condition, snapshot date between valid from and valid to .phonehist.bishist from this BSEC table. Using this join condition, we get from the BSEC table only the data which were valid for specific snapshot date for today. Then we join the next table, and you can see every historized join table which we join uses join condition, snapshot date between valid from and valid to, between dot from hist and dot bis hist. From every table, we get only the data which are valid for specific snapshot date. And then we use the usual business key joins. In this case, BKPF and BSEC are related using this for field, one done, booking, bookers, okay, Beleggnummer, Geschäftsjahr. And this is how we can work with the historized data. Imagine you can extend your snapshot table. You can create additional snapshots. For example, the last date in the previous months, or last date in the previous months, and so on. And in this case, we will expose for every snapshot date here the different sets of the surrogate keys. That means we can provide, we can expose in these fact transformations not only the actual data, but additionally the data for the old snapshots. And using the snapshot transformation dimensions, the snapshot table will be later used as snapshot dimension in our OLAP cubes. You can define the different snapshots, and you can have access to the data for the specific snapshot dates defined in the past. Of course, if you don't want to use snapshot transformation, you can say, for example, actual only. In this case, if you take a look on our view, there is no snapshot transformation anymore, but there is an additional condition that bis hist is equal 99991231. This is a rare condition to get only the actual data from our historized tables. But as I said, this snapshot transformation type and snapshot-based historization is very, very powerful. For example, for the first time, you can only use one snapshot with the actual date, but later you can extend your snapshot table by more snapshots, by other snapshot, and you will have access to the historical data in your data star without to change the your data model, without to change your the structure of your tabular OLAP cube, for example, or your Power BI model. Okay, as you can see, wait a moment, I will remove the filter. Okay, well, this is, for example, our fact transformation, but there is a table T003 which is not bound to, which is not used in our BSEC transformation, because this T003 table has no relation to the BSEC table, but has relation to the BKPF table. Let's add this, oops, wrong one. Let's add this table to our transformation. This is STG, T003V, and here we can decide which reference we will use. This is a new table, has a number 7. You can see here 7, and this last table number 7 is related to BKPF. BKPF, this is a table number 2. Okay, and there is a relationship. Okay, we have the relationships. They were defined in our meta connector, but of course you can, for example, define the references using this reference statement instead to use the existing reference stored in the model. Let's take a look on the view. Exactly, there is a new table added to our transformation. There is a join condition. Okay, and now we have to expose the new field, the surrogate key from the new table. This is the SATS ID. column, and we will call it fkt003, for example. Okay, save. Okay, let me add this statement. This statement will convert the zero values or null values into the zero. It is just the way how to process the missing data, and the dimensions, they will be replaced by the default member, or it's very easy, pretty standard way how to work with the missing data in the dimensions. Okay, then I will add the calendar dimension to our fact transformation. In the backupf table, there is a column called boodad, booking date, and I will use this boodad value as as calendar dimension. I will as calendar dimension. But boodad column, this is a date or string column. The string column contains the date in format year, month, date, and I will convert this string field into ID from my calendar dimension. How I can do that easy? It is to do that we can use AnalyticsCreator macros. Macros is very powerful tool in AnalyticsCreator. This is a small transformation brick, and for example, we have here the macro subdate to ID. Let me use it. Subdate to ID. This macro will convert my SIP date into ID from calendar dimension. Okay, this is just the alias for the column which I use here as a reference statement, and we will call it fk.boodad. Okay, save. Okay, if I take a look on the view created by AnalyticsCreator, I can see that macro was replaced by this statement. And how it works, it's very, very easy. First, we have here the macro called date to ID. Let me take a look on this macro. Macro is very easy. It's just as a statement. It can be transactor square statement, I don't know, DAX statement, index statement. And in this statement, some parts of the statement were replaced by the placeholders. This is double.1, this is a placeholder. And later, when we call this macro, this double.1 will be replaced by the first parameter of our call. And this statement just convert the date into ID from calendar dimension. Calendar dimensions was created, I forgot to show it to you. Calendar dimension was created by AnalyticsCreator wizard. This is this one. This is just the view. You can modify this view, no problem. And this view will provide us with calendar dimension for specific time period from 1918 until up to 2040. And you can extend this view, no problem. And for every, there is the primary key in this calendar dimension, and this macro is just convert the date into ID from this calendar dimension, edit macro. And but in SIP date, it is not the date, but it is a string. And how we can convert the SIP date from calendar into calendar ID from calendar dimension? Let me edit this macro. You can see first we convert the SIP date into the date time in our case, using this 112 format. This is a format of SIP date, and then we call date to ID macro. You can call macros in macros. It's very easy. And this macro in our fact transformation will be translated, and you can see this is just a macro text. And double.1 was replaced by the 2.boodad. Such macros you can create your own macros and use the macros everywhere where you want, and this is a central place to store, for example, some transformation bricks. And if I modify my macro, every transformation, every place where the macro was used will be accordingly changed. Okay, we just added calendar dimension. Let's add some measures. There are some columns which we can use as measure. For example, I don't know, quantity, for example. Okay, quantity, and oops, sorry. For example, this is okay. Let's call it amount. Okay, we just added two columns to our fact transformation. This is quantity and amount. Okay, what I will do additionally. Okay, let's just synchronize our data warehouse, and I think our data warehouse is almost complete. Maybe what we have to do additionally, we should add some macros. What I will additionally do, this is a pretty complex transformation, and I will persist the data stored in this view using the persisting mechanism of AnalyticsCreator. Add persisting. Okay, the data from this view will be stored in the table fact persect. Okay, very good. Persist package. I have to add here the name of the persisting package where the persisting will be performed. PS1, for example. Finish. Okay, let me synchronize again. In this case, diagram will be recalculated and will look nicer. I hope yes. And persisting will be used to materialize the data stored in the view and store such data in the table. This table has the same structure like the view, and the persisting will be performed using this persisting package. If I click on the PP square, we can see the text of the storage procedure generated by AnalyticsCreator, and the storage procedure will be used to persist on table. We support different types of persisting. The full persisting means the content of the persisting table every time will be deleted, and the persisting table will be filled up every time completely from the data from the view. We support different kind of persisting, of materializing, like merge, historical, and so on. But in our case, we will use a full persisting. Okay. Okay. Here you can define the scripts executed before and after persisting. Okay. Nothing specific. Okay, and then the data mart layer. Data mart layer contains the structure of our tabular model, which we will generate. For every dimension or fact in my core layer, I can say if it should be used in the specific data star. We can define the different data stars. In our case, there is only one star which is defined. This is star called just star. And okay, and here you can see there are the dimensions, and this is the fact. Okay, let me rename. You can see here every object here has a technical name and friendly name. This friendly name will be used later to generate in our OLAP cube, in our Power BI model, which we will generate. And let me okay, rename it here. Call it fact. Or not, instead of fact, I will use just underscore bookings. Okay. Okay. Let me check. Well, and let's take a look on this effect transformation. Okay, but just technically, every transformation here, this is just the view. If I click on this, if I click on it, I can see this just select from the data from the core layer. Every column from the core layer will be exposed in specific view. If I click on this T-square, I can see the columns exposed by the specific view. And here, for example, I can see the all preferences which will be used to join our effect transformation with our dimensions. And here I can define the different measures. Let me create some measures. For example, amount, quantity, and you can see this measure name. Sure, you can create your own measure name. You can, for example, just write here amount or quantity, no problem. But the measure names in the Power BI model should be unique, and sometimes if you have thousands of different measures, it is difficult to have them unique, and therefore we can provide you with a specific mechanism to automatically generate the measure names. And in this case, the measure names will be generated by template. You can create some templates like aggregation name, column name, table name, and here in the column, okay, create some. Okay, and I will. This is the column parts at measure name. You can see how your measure will be called. Okay, the amount, let's see, quantity, and so on. Okay, then let me add some more information. For example, the KNA. This is our customer. Testing count. LFA, this is our vendor, and maybe, okay, I think it's enough. I just added, okay, some. Okay, this is wrong one. Or let me add one more transformation, for example, count rows. Count rows and then table name, and in this case I will use the specific tabular statement, and this tabular statement looks like row count is the name of this DAX statement, and save row count bookings, row count or count rows. Sorry, let me control DAX moment. I just checked the name of this DAX statement, count rows. Okay, I was wrong, sorry. Count rows is the name of this function. This is just a DAX function to calculate the number of rows and the booking table. Okay, well, we added some measures, and if you want, you can define the additional columns and so on. But for us, it's important. We generated our data warehouse, and now let's generate deployment package. And deployment package, this is a result of AnalyticsCreator, but is a result of, because until now we just created the model, and now we will create a data warehouse based on this model. Okay, and deploy, let's call it deploy Azure. Okay, and deployment package, this is a Visual Studio solution which we will generate, and this Visual Studio solution can be used to create your data warehouse and to deploy your data warehouse. And using this solution, you can deploy your data warehouse everywhere. Okay, we will deploy our data warehouse on our Azure server. On the server, we have here, we have here one empty database called AV. This database is empty, and I will deploy my SAP data warehouse there into this AV database. Okay, let me get connection. Name of the server. It is not necessary, but I can deploy directly from AnalyticsCreator. In this case, I click on deploy backpack. Here, server, DB name AV. I will use standard security. Okay. I will use 2019 compatibility level. Okay, then I will generate integration service packages, which I will execute locally on premise. Unfortunately, right now the SAP connector or SAP import pipeline of Azure Data Factory is has very poor functionality. Therefore, to import the big amount of the data, we continue usually to use SAP integration service packages. But if there is a Azure Data Factory pipeline or driver using which we can use to import the data from the SAP, we surely can generate the Azure Data Factory pipelines. Okay, we will generate integration service packages. We'll set the compatibility level. Azure integration service packages can be used, of course, on with your Data Factory too. We will deploy SSS configuration environment variable. We will generate the tabular OLAP model, and here we will deploy this model directly to the Power BI. And our Power BI, let me show it to you. We have the Power BI. Our Power BI, this is this one. We have here the AV workspace, and this is the Power BI Premium workspace. And this workspace has the XML endpoint, and using this XML endpoint, we can generate the data connectors directly in Power BI, and we will do it. Just have to add the Power BI XML endpoint address here. DB name, this is the name of our database. Let's call it SAP GWH. Then I have to add here my login. This is Power BI login. AnalyticsCreator.com. And create cube during deployment. Important is compatibility level. And I hope. Oh, sorry. There is something wrong. One moment, please. Error. Okay. Sorry, this is a demo, a test version or beta version of AnalyticsCreator which I use, and there's something wrong with this version. But one moment, I hope we can fix. I can fix this one. One moment, I will shortly interrupt my demonstration. And sorry, I have to check here something. One moment, I need maybe 2 or 3 minutes. Okay, sorry, I think I found it. Okay, I will continue. Moment. Okay, demonstration. Okay, sorry, I forgot to set here. This is just okay. Start demo. I hope I forgot nothing. Yes, and now we will generate our deployment package. Sorry for this small interruption. Okay, server, database, okay, compatibility level, and let's click on deploy. And now the deployment package will be generated, and our database or data warehouse will be deployed. What will be done now? First, we generate the DECPAC file. You can see this option, generate DECPAC file. DECPAC file, this is the most modern way how to deploy the databases using AnalyticsCreator. And sorry, using not Analytics, using SQL Server this is a SQL Server tool or SQL Server capability. Using the DECPAC files, you can deploy your databases. You can use SQL Server Management Studio to deploy DECPAC files, or you can use a special utility of Microsoft, SQL package.exe, and using this utility, you can deploy your SQL, your DECPAC files. Okay, now this DECPAC file will be deployed to our SQL Server database. It takes some time. Unfortunately, our Azure database or our Azure server isn't very performant, and we use it only for demo. Therefore, it will take some time. And now that this DECPAC file will be deployed, maybe we can take a look to our AnalyticsCreator to our Azure database. This database was empty. Now let me click on refresh. Okay, you can see the deployment process is will be performed. There are, for example, the new tables generated by AnalyticsCreator. There are the views and so on. But as I said, because our Azure database is not very performant, it can take up to 5 minutes. Okay, and additionally, after this deployment package, DECPAC file is deployed, first the integration service packages will be generated, and then we will generate the tabular OLAP model on our Power BI in cloud. But we will, let's wait a little bit. Maybe somebody have questions during deployment is performed. I can answer maybe the questions.
Yes, please ask Dimitri for the question. Have something you have in mind.
Okay, then if there is no question, let's wait a little bit.
Meanwhile, I like to recommend our new webpage. There are some new pages there, also about the architecture of AnalyticsCreator. It's pretty new. Just 1 week ago, we have gone live with this picture, so you understand better how it works. This is also what I want to show you today, which we had problem with the connection. You can see this also on our webpage. Everything what is in my presentation you find in at the webpage. And also the separated use cases. So if you go on solutions, use cases, you see many of the possibilities you can do with AnalyticsCreator. And you have a little overview of at the moment 10 use cases. And if you click on the use cases, you can do a detailed description of what you can do with AnalyticsCreator in this special use case.
Okay, sorry, there is one small error, because I started AnalyticsCreator using the same account on other computer to find the reason of the error. Therefore, our packages were not generated. Let me start AnalyticsCreator one more time and to okay, this is just a small security problem. No problem. We generated SQL Server database. We generated OLAP cube right now, and now the only what we have to do. Let me open this our repository again. We have to generate integration service packages. I will check out the generation of DECPAC and OLAP cubes, and we'll generate only integration service packages. No problem. You can see the packages will be generated. Okay, packages are generated. Okay, let's take a look at what we did. First, we deployed this AV database. Refresh. Okay, and this database, this is our data warehouse, contains necessary tables and so on, but every table is empty right now. Then we generated Power BI OLAP cube. Let's take a look on our Power BI OLAP cube. Power BI. And here you can see in our AV workspace, there is a new data connector, this sub DWH. Okay, this is not procedured right now, but you can see there are our facts and dimensions. Okay, and now we will we generated additional integration service packages. Let me open this to Visual Studio Solution. Our solution. Okay, sorry, wait a moment. Where did we store in the ctemp? Okay. Ctemp. Every time when we generate new Visual Studio, new deployment, the new subdirectory will be generated. And this is the Visual Studio solution. This is the SQL Server Data Tools solution. And here you can see integration service packages. For example, if you take a look on the import package, to import the data from SAP, you can see that we use, for example, here, this is a datawarehouse connector. We generate integration service packages using datawarehouse connector. To generate packages, you don't need the datawarehouse license, but you need datawarehouse license to execute the packages. And let's just, okay, you can see for every SAP table, there is an own container, and every table will be imported in parallel. To historize the table, this is a historization package, and here are the different tasks to execute the historization storage procedure. The persisting package to execute the persisting storage procedure, and additionally there is a workflow package. Workflow package will be used to execute every package in the correct order. And let me execute the workflow package. I hope it will work. I hope our SAP system, demo SAP system, is available now. Let's check. Okay, the data loading is performing. We import now the data from the SAP system into our Azure SQL Server database. Okay. The import is still on. Okay, this is the biggest table. This is a booking position table. But I hope it is done very soon. Okay, it's done. Now the historization will be performed. Important is that for historization and persisting storage, we use storage procedures. Therefore, every process will be done directly on the server without to use. We don't use the functionality of this, for example, integration service packages or for Azure pipelines. Therefore, all data will be historized directly on the server. There is no data flow between the server, for example, and our and my computer, where the packages will be executed. Okay, and you can see workflow package is completed, and if we take a look on our tables, for example, import table, select, we can see the table is filled up. Okay, let's go to our Power BI model. And this sub DWH, the only what we have to do, we should refresh the credentials. Okay, because, okay, data source credentials, edit credentials, sign in. Okay, I hope credentials were refreshed. And now we are able to refresh our data set. We hope, okay, is refreshing, you can see. Okay, meanwhile, let me start my Power BI desktop. Okay, data set is refreshed. Okay, and now we can generate our reports and so on. I will start our desktop. Our data warehouse is created, and data are loaded into our Azure database. The Power BI model was created too. And let me data. Okay, I'm connecting to our Power BI model using my data warehouse Power BI desktop, and here you can see there is a list of our dimensions and tables. Okay, there is a structure of our data. This is our data model, the poor data star. In the middle, this is a booking fact transformation, and the different dimensions. Okay, let me try to add something, I don't know, for example, document types. Okay, main document, I don't know what is doc type or type. Sorry, or type. Document type, for example. Type. Okay, document type we will take, for example. Then let me add, I don't know, customer name, for example. And from the booking table, we will take some measures, for example. Sum of amount. Okay. I don't know what we can additionally do. For example, we can take our vendors, name of the vendor, for example. And add some measures. And so on. As I said, our model is now ready. You can create your Power BI reports using this model. And our model is located on Azure. SQL Server database located on Azure. Power BI model is on Azure. Okay, integration service packages, we executed them locally, but you can transfer your packages to the Azure Data Factory too. Therefore, we created our model and it can be used to create the reports. Well, I think my presentation is finished. If you have questions, please, you can ask me.
Are there some questions about the process? If you like, you can try it by yourself. As maybe you know, you can go on our website and ask for a trail. So the trail you can have 30 days, and there is nothing locked, so you can try everything and use also the outcome of the thing what you have done. Yeah, just try it, and if you have some questions, you can also ask us. And the best is, of course, to watch the videos first, special data sources. Just ask us, and we will help you and support you to get it run in AnalyticsCreator.
Okay, then thank you very much. And
yeah, if there are no questions, then we end this session now. Thanks a lot.